Greetings, this is Mr. Anderson from Kellogg Community College, and I'm going to follow up the last video you saw in this section where we are taking sines and cosines and we are applying amplitude, omega shifts, and also a phase shifting as well as vertical shifting. So a lot of different effects onto one graph, and this problem could take its own video, seriously, but we are going to do some problems after it by taking given amplitudes, phase shifting, and periods, and we're going to actually turn those into equations. So this is a pretty good video to watch. I would recommend sticking all the way through it. Now, one of the big tricks in dealing with this problem right away is dealing with an omega that is ostensibly negative, but we can actually take care of that because we have something called the odd-even functions, that the cosine of negative x is equivalent to the cosine of x. And we looked at that at an earlier chapter dealing with x values, and the x values, whether you go in a clockwise or counterclockwise rotation through the unit circle, have the same values, and they are basically equivalent. So what we are about to do is a little trickery here to get rid of this negative inside of this problem. One of the common mistakes made is that people just drop off this negative here, and you can't actually do that. You can't just drop off the negative because this negative is actually part of this entire effect on x. So what you have to do is factor out a -1. And those of you looking at your solution manual probably have seen that you can't just take this negative out of the problem or just drop it in this kind of odd-even formula perspective. You have to factor out the -1, which will change your phi, and your phi is your part of your phase shift here. So we've got -3 cosine, and then we've got negative, and this is the negative we're factoring out. We're factoring out this -1, so now what we have is we have a 2x instead of a -2x, but we have a minus pi over 2, and that minus pi over 2 is now different than this. I mean, I think if you just drop the negative, you would have this shifting in the wrong direction. And then -1. And now, since we have our odd-even function basically stated here, we can just take this -1 and say, okay, well, so negative x is the same thing as x, so this negative application of x is going to be the same thing as positive application of x. So therefore, we're going to have y is equal to -3 cosine 2x minus pi over 2 minus 1. All right, so there that is. There is your beautiful function now. Again, that's the negative taken out of it. And this actually got brought up by several students who looked in their book and realized that there's a very similar problem in the homework, but it's sine instead of cosine. Now, sine, unfortunately, doesn't have the same kind of simplistic process to it like cosine does. So the sine of negative x is the same thing as negative sine of x. So what would actually happen is that negative, if once factored, would then get moved to the front, and that would change your amplitude of the problem. But what I'm about to do is I'm about to apply these 4 steps here. I'm going to first of all take care of the amplitude. I'm going to do that in drawing the cosine wave. Then I'm going to work with my my omega, and then I'll work with my phase shift, and then I will work with my vertical shift. All right, so the first thing I want to do is working with a cosine wave, and let's remind ourselves that we're going to deal with this function over here, this -3 cosine 2x minus pi over 2 minus 1. The first thing I want to do is I want to think about what is one period's length of a cosine wave, and that's going to be 2 pi. And my requirement on the homework is to always go 2 periods, so we can kind of go beyond what the book wants us to do, and we can actually think beyond just a normal unit circle here. So we're now going to also deal with an amplitude. Let's put my heights here and here. This is going to be 3 and -3. And I will now look at this wave, and cosine starts high, medium, low, medium, high, but I have to be very careful to note that this is a -3 cosine of x. Cosine of this x, I should say. So it's going to start low in this case, because a normal cosine wave is high, medium, low, medium, high, but this is going to be low, medium, high, medium, low. Now, if you have a unit circle in front of you, you can actually verify, the values of cosine at these marks of, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And you can see that it was -1, 0, 1. But again, I'm adjusting for my amplitude here. Now, this cycle will repeat after itself: low, medium, high, medium, low. All right, so there it is. There's my beautiful cosine wave. Okay, so the next thing I'm going to do is I'm going to work with omega. My omega is 2. Now, what I have to do to get my proper period now, I have to take my current period, which is 2 pi, and then I have to divide it by omega. And in this case, my omega is 2, so this is now doubling in speed. So we're going to finish our first cycle within pi distance instead of 2 pi distance. So this is going to be my first period, and this is going to be my second period. Now, the picture is going to look exactly the same, but the x values are going to be completely different. And I like to draw this extra drawing here just so I can now put that at 3. I can now easily kind of like adjust for my shift, which my phase shift is going to be, all right, missed it out a little bit. The phase shift is going to be then affected by my phi there. All right, so -3. This is now no longer pi over 2. This is going to be pi over 4. And that's going to be, pi over 2 up here. And in fact, it might behoove us to label our points here, pi over 2, 3. All right, and then this is this is 1 pi over 4, 2 pi over 4. This here is 3 pi over 4. And I can put that there, 3 pi over 4. And then 4 pi over 4, well, that's going to be pi, and pi, comma, -3. And then 5 pi over 4, and then 6 pi over 4. But 6 pi over 4 is 6 pi over 4, excuse me, is reducible down to 3 pi over 2, comma, 3. 7 pi over 4, and then finally 8 pi over 4, or 2 pi, comma, -3. Okay, now it's important to know these gaps, or these spaces here, because what we're about to do to go from this second step to the third step here, we have to now figure out, geez, where am I going to start shifting this function? Because this phase shift is basically affected by this pi over 2. And you take your phi, and divide it by your omega, and this gives us your phase shift. So I've got pi over 2, and I'm dividing it by my omega. My omega is 2, but pi over 2 divided by 2 is best to be multiplied by 1/2. For those of you new to my videos, I do not let my students use calculators during this section, which is the reason why all of these are going to look the same, because we're not trying to replicate what a graphing calculator can do. We're trying to get students to see what happens with the graph and the points at a more granular level here. If they have the calculator, great. The calculator can do everything in one swoop. But if they don't have the technology, they should be able to manipulate it this way. So it looks like I am going to have a phase shift of -4. And according to my notes that we set up in our class, if this is a minus, it gets shifted to the right. If it's a plus, it gets shifted to the left. So this is going to be a pi over 4 shift to the right, which means that this entire graph is going to get shifted 1 tick mark to the right. Now, what that means is that this low, medium, high, medium, low is actually going to start 1 tick mark over. Low, medium, high, medium, low, because everything got moved over 1 space. Low, medium, high, medium, low. And the pattern would continue on from there. Low, medium, high, medium. So there you go. All right, so there it is. There is my new graph, and you saw me kind of extend this little tail right here. And this gives me my points that I need. Now, again, the x-axis didn't move at all, so this is still the origin. And this, yeah, I know this does look like a negative sine graph, or a negative amplitude graph for sine. But this is my new shifted, phase-shifted cosine graph. And I'm going to label some important points. So this was the origin. I can just label that 0. And this is no longer, this is pi over 4. And pi over 4 is no longer an intercept. Pi over 4 is at -3. And this is pi over 2, because this would be 2 pi's over 4. And then this would be 3 pi over 4, comma, 3. 4 pi over 4 are just pi, and then 5 pi over 4, comma, -3. And then we have 6 pi over 4, but 6 pi over 4, the better way to write that is 3 pi over 2. And by better, I mean the way you have to write it. And then finally 7 pi over, or not finally, but 7 pi over 4, comma, 3. Forgot my little parentheses there. And then 8 pi over 4, which is just 2 pi. So for my final part of graphing this problem right here, you'll notice it's a -1. So what I like to do is kind of put in all of my tick marks here for my amplitude, and I'm just going to drop all of these by 1. Which means that no longer is this 3 going to be a 3, it's going to be a 2. And that's going to be a 1, and that's going to be a 0. So this is the new the x-axis. And this is going to be -4. But in terms of my drawing, you can see that I can just go medium, low, medium, high, medium, low, medium, high, medium. All right, so there. That kind of gives me my new graph, and what it also does too, it now has every single point, it can be relabeled. Now what's kind of convenient is that since I took some time on this third part here and just did all my points methodically from left to right, I can do all my points methodically going left to right based on this. The origin used to be 0, 0, is no longer 0, 0. This initial point is now at -1. So that's the point of 0, comma, -1. And then down below here, this is pi over 4, comma, -4. Then pi over 2, comma, -1. Then at the very top, we have 3 pi over 4, comma, 2. And then here at pi, we have pi, comma, -1. Again, all of these old x-intercepts are now that x, comma, -1. And I'm going to label those. 5 pi over 4, comma, -4. And then 3 pi over 2, comma, -1. And almost done. We got 2 more points to go. 7 pi over 4, comma, all the way up to 2. And then we have 2 pi, comma, -1. And we're almost done here. Let's do a little domain and range. The domain of this function is going to be all real numbers, which in interval notation, the book uses as -infinity to +infinity. I would accept real if you wanted to write that, or in set notation, x is the element of real numbers. I mean, I've shown you in class a bunch of different ways to do this, but the book will probably use interval notation because and it's actually a little easier with interval notation since we do not have exclusions like asymptote lines. And the real answer for this, or the range, excuse me, answer for this is going to be from -4 to the positive height of 2. And make sure you have your brackets there. And if you decided to use set notation, this would be y, and I like putting this little line here, y is knocking on the door, that -4 is less than or equal to y, which is less than or equal to 2. Here's my little set notation there. Sorry for the little scribble ribble there. Actually put my y in the wrong spot. Since this is y is between these two numbers, y is greater than or equal to -4, y is less than or equal to 2. Alright, so yeah, that is quite the problem, isn't it? Can't give you too many of those on the test. Probably not more than one. But I want to now spend the second part of this video to talk about writing equations from given characteristics. Now, I'm going to move this forward. All this is going to go away. Poof, all that work, all that work. All right, so here's what we're going to do. We're going to look at writing an equation of a sine function that has the following characteristics. So for this problem, we are going to set up the general formula for, for our sine function, because we're going to be given an amplitude, a period, a phase shift, and then what we're going to have to do is write down what that equation is. Now this is for sine, so y is going to be equal to a sine of omega x minus phi. Now, a couple things to note, that sine has a period of 2 pi. So therefore, the period function for sine waves, cosine waves, and basically anything that's not tangent or cotangent is going to be 2 pi divided by omega. Our phase shift equation is going to be our phi divided by omega. Now, one thing you should note is that this equation has a minus as the default for this phase shift here, or phi in this case. So whatever we get for phi, we have to put it back in front, or sorry, behind the subtraction sign. So that means if this phi comes out positive, it would be then negative in this problem. And let's kind of take this part by part, and we're going to have y equals a, so that's the amplitude of 3, sine, and now we need our omega. Now, since we know that our period is 2 pi divided by omega, and our period is pi over 2, then due to the transitive property, we can set 2 pi omega equal to pi over 2. And do some cross multiplication. So pi times omega is pi omega, and 2 times 2 pi is 4 pi. Divide both sides by pi, because we want to get omega by itself. And here my omega is equal to 4. So now this is 3 sine 4x. Now let's figure out our phi, because we know the phase shift. Now phase shift is equal to phi over w, and phase shift is 2, again, due to the transitive property that 2 is equal to phi divided by omega. And our omega, as we found in the previous step, was 4. So getting phi by itself, we multiply both sides by 4, cross multiply. Your phi is going to be equal to 8. Now the 8 gets plugged into this equation right there, so this is minus 8, and we close that off, and that's the end of finding that answer. Then we go into this problem. We'll kind of run through the same thing. The amplitude is the easiest, because that's just plug it in. But now we have a period of 3 pi. So what we're going to do is we're going to take our period of 3 pi and set that equal to 2 pi over omega, and we can cross multiply. But also I want to show you a pretty cool step. If you have a cross multiplication problem or two fractions set equal to each other, you can flip-flop the places of any diagonal. So this now becomes omega divided by 1 is equal to 2 pi divided by 3 pi. This is going to make things a lot faster in the future when we do some of our manipulations here. So the pi's then simplify to 1, and so my omega is 2/3. My omega is 2/3, so now I have a 2/3 x, and then I'm going to take my phase shift, which is negative 1/3. My phase shift, I'm going to set that equal to, in this case, phi divided by 2/3. And I think the best reaction here is, you could have, multiplied it by 3/2, but I think I'm going to be doing that. I'm going to have to undo it anyway, because the opposite of dividing by 2/3 is multiplying by 2/3. So dividing by 2/3, multiplying by 2/3, that's going to make a 1. So 5 is going to be by itself. And on the other side, we're going to multiply by 2/3 as well. And what we get is 2 times negative 1 is negative 2. 3 times 3 is 9. So phi is equal to negative 2/9. Now you'll note that our equation has a negative here, so that's going to be a positive 2/9. And that would be the end of that equation. Again, the common mistakes that are made here is that you will unfortunately forget that this is a minus, so your 8 has to be a minus, not a positive 8, and this negative 2/9 will have to be a positive 2/9 as you apply a negative 2/9 behind the subtraction sign, so negative 2/9 is positive 2/9. Well, thank you for watching this video. Hopefully it'll clear up a lot of questions as you do this tricky part of the homework here, and thank you again for watching.